This is lesson 2.2, linear relations and functions. So this first part here is going to talk about linear and nonlinear. Anytime you see the word linear, you think of points that are going to be in a straight line. Nonlinear means it's not a straight line. So think about the word line is within linear. So if it's a curved graph or a circle or something like that, that's nonlinear. Anything that is a straight line is linear. So equations such as x plus y equals 5 is called a linear equation. A linear equation has no operations other than addition, subtraction, or multiplication of a variable by a constant. So the variables may not be multiplied together, so like x, y, so you can't have this, two variables next to each other. Or the variable can't appear in the denominator, like this one, because then they'll have a negative exponent. So it doesn't have any exponents other than 1. So you can see y squared on this one, and x to the 1/2, or the square root of x is actually x to the 1/2 power. And if I rewrite this one, it's like x to the negative 1/2. So it can't have any other exponents other than 1. So you can see on the linear equation side, you have 4x minus 5y equals 16, x equals 10, and so forth. You're allowed to have a fraction as the constant, but your variable can't be the denominator. So just ask yourself, can it be rewritten in the form y equals mx plus b? Hopefully that rings a bell from last year. M and b are real numbers. We'll talk about that later. M is the slope, b is the y-intercept. So if it can be rearranged and written in y equals mx plus b form, then it is a linear function, which would be a straight line on the graph. This video is asking you, or in Delta Math, it's going to ask you for a code word. So just to check to make sure you're listening to the video, the code word you need to select from the multiple choice answers is banana. So make sure you get that one right. That should be an easy one. So the code word for this video is banana. All right, so let's identify some linear functions. So we have 8 equations here. We need to circle the ones that are linear and explain the ones that are not. So I'm going to go through and circle the ones that are linear first. Remember that anything you can be rewritten in y equals mx plus b form. So that's number 1. It has y equals mx part, but the plus b would be like plus 0, so that one's fine. Number 2 is also linear. It's just the b and the mx part are flipped. Number 3 is also linear. You could subtract the 2x from both sides and get y alone there. Number 6 is linear. If you just bring the 8 to the opposite side, then y is alone on that one. And number 7 is also linear. Now this one might be harder to see that because it's in function notation, g of x. Remember, we can replace that, and it's kind of like y equals 8, which is in the form y equals mx plus b, but the slope is 0, so the b value is just 8 there. So these remaining 3 are not linear, and let's talk about why. So this one had an exponent other than 1. So that one is not. Number 5, this x had a variable in the denominator. So you're not allowed to have the variable in the denominator. And number 8, it's in function notation, so think about that as y is the square root of x plus 3. We talked about previously that the square root of x is like x to the 1/2, so your exponent is not 1. So those will not give you straight lines on the graph. So now let's evaluate a linear function. The growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches, so that's important to know what that represents, the total height in inches, and x days after the initial measurement. So part A, how tall is the sample after 3 days? So this part here, the 325, is the initial measurement. I want to know what it's going to be after 3 days. And remember, x was days. So we're going to set x equals 3 into this function. So we're kind of taking f of 3. So where that x was after the 5.9, we're going to replace it with a 3 and see what the output would be. So if you do the math, whether it's mentally or with a calculator, you're going to get 20.95 inches. So that is your final answer. Part B, the term 3.25 in the function represents the height of the grass when it was initially measured. The sample is how many times as tall after 3 days. So all we have to do here is take our amount after 3 days and divide it by the initial measurement to see how many times this would be. So it's about 6.446. Let's round that to the nearest tenth, so you can say about 6.4 times as tall. All right, moving on. So there are some practice problems here. I would like you to try both of these on your own and see what you can work through and come up with. So you try these ones. You don't have to enter them into Delta Math at all, just we'll check them the following day. So try both of those. Let's talk about standard form. So standard form is in the form capital A, X plus capital B, Y equals capital C. A, B, and C are integers, so remember that is a positive or negative whole number. Can't be a decimal, can't be a fraction. The A, B, C numbers can't have any common factor that you can divide out of all three, so it's in lowest terms kind of thing. And the leading coefficient, the A value, has to be a positive number, so it can't be like a negative 2x to start. So we're going to write this equation in standard form and identify the A, B, and C coefficients. So the first thing we want to do, I'm going to rewrite this original equation. I'm going to leave some space there, and you'll see why in a second. So one of the things students don't like are fractions in the denominator. So let's wipe that out. So let's multiply all terms by negative 10. And by doing that, you're going to see this wipes out the 10 and the negative, so it's going to be a 3x. Over here, it's going to be a negative 80y, and then this is going to be a plus 150. So now I'm dealing with just integer values. If you see up at the top, remember I want it to be ax plus by equals c. So I want your x and y's on the left with just a single number on the right. So right now I have the c value, 150 on the right side, but the negative 80y needs to move to the opposite side. So we're going to add 80y to both sides. So this is going to look like 3x plus 80y equals 150. So this is in the form ax plus by equals c. And I'll highlight these numbers. So in the 3 position, it's the A. The B position, it's the 80. And the C position has 150. Now you should double check. So A is positive. It's a 3. They're all integers. There's no decimals or fractions. 380 and 150 aren't divisible by any same number, so it doesn't have a GCF, more than 1. So that is your final answer there. And we have to list the A number is 3, the B is 80, and the C is 150. All right, so let's try 2 more quick ones here. So on this problem, I want the 9y to come to the opposite side. So you're going to subtract it here. This is going to be negative 8x minus 9y equals negative 6. The leading coefficient has to be a positive, so we're going to divide everything by a negative 1 to then get ax plus 9y equals a positive 6. So here it's in standard form. The a value is an 8, the b value is a 9, and the c value is a 6. They're all integers. A is positive, and 8, 9, and 6, you can't divide them by anything. So the GCF is 1. Kind of similar step with number 10. The 4x now needs to move over, so we're going to subtract 4x. I'm going to write negative 4x first, so that's an ax form. By equals the 8c. I'm going to divide these all by a negative 4 because they're all divisible by 4, plus I don't want the x coefficient to be a negative. So this is going to be x minus 3y equals negative 2. So that's the standard form. So a is going to be a 1, b is negative 3, and c is negative 2. And the last concept is using intercepts to graph a line. So we're going to find the x-intercept and the y-intercept and then graph the equation. So the first thing I want to do is move the 8 to the opposite side. So this is going to be 2x minus 3y equals negative 8. So graphing by intercepts is helpful when it's in standard form. To find the x-intercept, and this is what it's going to ask you in the Delta Math questions, you're going to set y equal to 0 and solve for x. So in our equation over there, it's going to be 2x minus 3. You're going to replace the y with a 0 and solve this little one for x. So this becomes 0. You just have a mini one step. 2x equals negative 8. Divide by 2. The x-intercept is a negative 4. As an ordered pair, the x-intercept always has some number and then 0 for x and y. So this ordered pair is going to be negative 4, 0, which on our graph is going left 4, and it's on the x-axis there. Likewise, we do something similar to find the y-intercept. This time, we're going to set the other variable, set x equal to 0, and solve for y. So we're going to have 2 times 0 minus 3y equals negative 8. That part is 0, so you have negative 3y equals negative 8. Divide both sides by a negative 3. Y is going to be about 2 2/3 here. So as an ordered pair for the y-intercept, you're going to have 0 for the x and a number for the y. So this ordered pair is 0, 2 2/3, which means you're not going any left and right, but you're going up 2 2/3 more. So it's about here. And then we got to draw a line connecting these 2 points. Make sure the ends of your line have arrows on them. So graphing by intercepts, you have 1 point on the x-axis, 1 point on the y-axis, and then you just graph your line. So I'm not going to do both of these here just because I don't want the video to be too much longer. But let's look at the first one. So if I want the x-intercept, that means like y is 0. So you're going to have 2x plus 7 times 0 equals 14. These are going to work out nicely. 2x equals 14, so x is 7, which is the ordered pair 7, 0, which is right there. The y-intercept, I'm going to replace x as 0 and solve for y. So that part's 0, 7y equals 14, so y has to be 2. So that's the ordered pair 0, 2, which is up to. And then try to use like a straight edge if we're actually graphing on paper and not in a digital format. But again, you should have one dot on the x-axis, one on the y-axis. Draw your line straight and put arrows on the end. And we're going to skip this last one, so don't worry about that. And that is the end. So make sure you answer the Google form, or not Google form, the Delta Math questions. Remember the code word I said in the beginning of the video, and answer the other questions in there.